Suppose we have this huge number here, the square root of 72 plus, and then inside that, the square root of 72 plus the square root of 72, and so on. So we have a bunch of square roots, a nested square root, and precisely 72 72s. So 72 square roots and 72 72s. The question is, what is the floor of this number? So in other words, what's the biggest integer less than or equal to this number? Now, what's really nice about this solution is that involves a really slick trick, and it's actually quite a short solution. What we're going to do here is firstly make an observation that pretty clearly x is bigger than root 64, which is 8. And that's because 72 is obviously bigger than 64, and all of this stuff here is positive. Great, so x is definitely bigger than 8. And now I'm going to show that x is less than 9 with this really, really cool trick. What I'm going to do is get rid of this 72 here, or change that 72 to an 81. So now this number here is an upper bound. So all I've done is made the 72 slightly bigger, made it 81. Square root of 81, what's that? Well, that's 9. So this square root here I can get rid of and replace that with 9. Now, what's 72 plus 9? That's 81 again. So this square root here, it's getting a bit messy, becomes 81. And so this square root here, when I square root it, becomes 9 again. And then I'm going to get 72 plus 9 again, which is 81, which is going to cancel to 9. So it kind of collapses in on itself all the way down to the very last square root, and I'm going to get that x is less than square root of 72 plus 9, which is square root 81, which is 9. So a really nice way to prove that x must be less than 9. And so x is between 8 and 9. And so therefore the floor of x must be 8.